Alright guys, welcome to this page of the notes, and what we're going to do is these three problems are simply designed for one reason: to help us practice finding vertical asymptotes and practicing those three rules we just talked about for horizontal asymptotes. Please take as long as you need to familiarize yourself with the three rules, but I think as we go through a couple of example problems and explain to you how the three rules work for finding horizontal asymptote, it'll make a lot of sense and you'll catch on real quick. First, vertical asymptotes. You will always need to be able to find a vertical asymptote. I will always start. I'll just start by finding a vertical asymptote. So we know we find the vertical asymptote by setting the denominator equal to 0. So x plus 1 equals 0. Which means x is equal to -1. I know that -1 is going to be my excluded value in the domain. Right? -1 is not allowed because it gives me division by 0, and I know that on a graph that will show up as a vertical asymptote. So I now know that I have a vertical asymptote at x equals -1. Okay, now that I know where my vertical asymptote is at, let's find our horizontal asymptote, if there is one. Now remember the way this works. You need to think of the polynomial on the top and the polynomial on the bottom, and you need to find the degree. So I take a look at what I've been given. The polynomial on the top is just an x squared. I take the largest power, which is 2, and so the polynomial on the top is degree 2. Let me write that down for you. Remember, ax is the polynomial on the top, so ax is degree 2. Bx is the polynomial in the bottom. Well, I have an x plus 1. That x is to the first power. That is the largest power. And so the degree of the bottom polynomial is 1. Now here's what I know. Ax is greater than bx, right? The degree of the top, 2, is greater than the degree of the bottom, 1. Do you remember which rule that is? Yeah, it's rule number 1. Rule number 1 said if the degree of ax is greater than the degree of b of x, which is rule number 1, then there is no horizontal asymptote. So I now know that there is no horizontal asymptote because it is rule number 1. Rule number 1. No horizontal asymptote. Now let me show you. I actually have this function graphed for you. Check out the previous page. That little chart that I gave you, I told you guys we would come back to. Here's that function that you and I just did. We found that there should be a vertical asymptote at -1, and look at that. There it is right there. We also discovered that thanks to rule number 1, because the degree of the top is greater than the degree of the bottom, there is no horizontal asymptote. That's rule number 1, no horizontal asymptote. But then I said, which we'll take a look at later how you find, there is no horizontal asymptote because actually rule number 1 gives you a slanted asymptote. Well, if I take a look at this, you guys can probably pretty easily see that there does appear to be an asymptote that runs right through there. There it is right there, that slanted asymptote. So rule number 1, there is no horizontal asymptote because there's actually a slanted asymptote, an oblique asymptote, and we'll talk about how you guys find that later on. Let's try a couple more. Back to this page. Here we go. I have another one for you. F of x is equal to 3 over x squared minus 1. Start by finding the vertical asymptote, and I do that by doing x squared minus 1 is equal to 0, which means x squared is equal to 1. Take the square root of both sides. Don't forget to do plus or minus, and x is equal to plus or minus 1. Sorry, that got weird. Okay, x is equal to plus or minus 1. Now remember, these are my excluded values. They are not part of the domain because they give me division by 0, and in most cases, those will show up as vertical asymptotes on my graph. So I'm pretty sure at this point I will have a vertical asymptote at x equals plus and minus 1. I have 2 vertical asymptotes, and that's okay. You can have more than one vertical asymptote. But let's check the horizontal asymptote. Well, AX the degree of the polynomial in the top, well, I don't have a variable. I just have a 3. That means the degree is 0. There is no variable, so the degree is 0. B of x, the polynomial in the bottom, well, I have an x squared. That's the largest power, so that's the degree of my polynomial, 2. In this case, a of x is less than b of x, right? The degree of the top is less than the degree of the bottom, and hopefully you guys remember that that is rule number 2. Rule number 2, and so here's what I now know. I have a horizontal asymptote at, do you remember what the rule said? Yeah, if the degree of the top is less than the degree of the bottom, the x-axis, or y equals 0, is your horizontal asymptote, and again, that's rule number 2. Well, let's check and see. I go back here where I have actually graphed the function for you. We said, thanks to setting the denominator equal to 0, I should have a vertical asymptote at plus and minus 1. And look at that, I sure do. There's a vertical asymptote at negative 1. There's a vertical asymptote at positive 1. And then thanks to the degree of the top being less than the degree of the bottom, I believe, thanks to rule number 2, I should have a horizontal asymptote that is the x-axis. And sure enough, right there at y equals 0, the x-axis is my horizontal asymptote. Great, we're doing good. I'm feeling great about these rules. Let's keep going. My next rational function, again, start with the vertical asymptote. So my denominator equal to 0. So x minus 3 is equal to 0. I wind up with x is equal to 3. And so I feel pretty confident I should wind up with a vertical asymptote at x equals 3. Why? Well, because if I plug in a 3, that'll give me division by 0. And in almost most cases, division by 0 will give you a vertical asymptote on the graph. We'll talk about when it doesn't and what you'll do at that point. But in this case, it will. It'll be a vertical asymptote at x equals 3. Now the horizontal asymptote. Well, I take a look at this and I see that the degree of the top, a of x, is equal to, well, I have 2x to the first. That's the only power I've got to the first. That has to be the degree of the top. The degree of the bottom. Again, I have an x to the first and then a minus 3. So the degree of the bottom is also 1. This means that a of x is equal to b of x. Sorry, the degree of the top is equal to the degree of the bottom. And do you remember what rule that is? Well, we've already done rule number 1, rule number 2, so probably by process of elimination, it's rule number 3. But what does that mean? All right, rule number 3. Here we go. Here's how this works. Remember, rule number 3 was a little weird. In rule number 3, we said the horizontal asymptote will be y equals, so y equals, and then that little formula I gave you said that it is y equals the leading coefficient of the top polynomial divided by the leading coefficient of the bottom polynomial. Well, I take a look at this. My polynomial on the top is in descending order. Must be in descending order. That means my leading coefficient is 2. So I take that leading coefficient of the top, which is 2, and I divide it by the leading coefficient of the bottom. Make sure the polynomial is in descending order. That way the leading coefficient is whoever is in front of that largest power of x. In this case, it's a 1. Well, what is 2 divided by 1? Yeah, it's just a 2. And so here's what I now know thanks to rule number 3. I have a horizontal asymptote at y equals 2. Y equals 2. Well, let's check and see if it actually works that way. Here's that function graph for you guys. We said I should have a vertical asymptote at x equals 3 because that's what gives me division by 0. And sure enough, right there, the scale is slightly changed. But if you take a quick look at it, you'll notice it's between 2 and 4, which would be 3. So a vertical asymptote at x equals 3. And then thanks to rule number 3, because the degree of the top was equal to the degree of the bottom, so I take the leading coefficient of the polynomial on the top divided by the leading coefficient of the polynomial at the bottom, and we got y equals 2. And sure enough, right there, y equals 2 is my horizontal asymptote. All right, so The way that you find vertical asymptotes, set the denominator equal to 0 and solve. We've been doing that, not a problem. But now we've got 3 rules. When we can't easily look at the function and just recognize what k is, no problem. We now have 3 rules to help us evaluate where that horizontal asymptote is going to be, if there even is one. We will practice this many, many more times on the following pages of the notes. I cannot wait to graph these functions with you, so let's get started. Head on over to the next page and I'll meet you guys there.